Hi, and welcome to Meshing with HyperMesh for explicit simulation. In explicit analysis, time step consideration is very important for computational efficiency. We have to mesh the model taking account of the minimum element length. Let's begin by first performing a check run. When the checking is done, let's review the starter output file. Search for nodal time step distribution. Here we can see the graph showing the percentage of nodes and the nodal time step. Ideally, you want to have a nodal time step as homogeneous as possible, meaning the majority of the nodes should have the same time step. Based on this graph, we can set the target nodal time step as 3e to the minus 6. The shortcut for check elements is F10. In here, we type in the desired failure criteria for minimum time step. We can see that the hood of the car fails the required time step. Let's isolate the component and activate a sign plot. Here we see the time step distribution of the hood, and we see that the minimum time step is much less than the required one. Next, we remesh the hood. Go to Auto Mesh panel, the shortcut is F12 key, and on the Auto Mesh panel go to QY Optimize and click Edit Criteria. In the Edit Criteria, go to Time Step Calculator. Here we input the value of our material. Based on material parameters and the target time step, the minimum length can be calculated. There are some preset materials available. Check the Use Minimum Length from Time Step Calculator to automatically input the calculated minimum length to meshing criteria and click Apply. It is advisable to set the target element size 50% bigger than the fail element size from the criteria. Make sure to choose the mixed mesh type and the align and size flow options activated. And also keep connectivity. In 2D panel quality index, we can review if there are any elements violating the thresholds from the mesh criteria. Here we see the minimum size is respected. Another useful panel is element cleanup, where we can check and edit the elements failing the meshing criteria. Smoothing can also be done to get smooth mesh flow lines. Let's check the minimum element length again. We see that the minimum time step is 3e to the minus 6, which is right on the target. Let's run the check run again. And review the starter output file. The 2/3 of all nodes respect the minimum nodal time step. Scroll to the bottom where we have a graph showing initial added mass estimation for DT Noda CST, or traditional mass scaling. In the first column we have the mass error being added at the first cycle. This is the added mass divided by the total mass of the model. In the second column, the target time step at a scaling factor of 0.9 is displayed. In the third column, the target time step at the scaling factor of 0.67 is listed. Above this table we have the graph showing mass error versus target time step. This concludes this exercise. Thanks for watching.